It's a trigonometry question and it's using some trig modeling, and we can see that it's trig modeling because we have the cos or sine function. So in this one it's a cos function and we can find that here. So we need to, for the first question, it's explaining the height of a seat on a Ferris wheel. So if you imagine a Ferris wheel, you have like one seat hanging here, and as it goes round it changes height. So it's just modeling the height of the seat on the Ferris wheel. So I think the first thing we should do on this question is probably to graph it. So we're going to go to our calculator, and it's a negative function. Make sure you're using the right negative button. And it's 15 cos of 1.2x. And we have our brackets, and then plus 17. The 17 is not in the brackets. That should be outside. It's always just the actual cos part, which is this bit here, the 1.2t, or for us 1.2 times x. And you can see from my graph, it's obviously not set up correctly with the axis. So we need to totally change all of this. So we're thinking it's probably going to be something to do with 0 and 360. So we need to have a much bigger range on the x values. It might be that it's not 360, but that's a good place to start with trigonometry. And let's just try putting this down to, let's try even just 10. Let's see what happens there. Okay, so we can start to see the graph much clearer. Let's go back to the window. Let's maybe change this one to 30. Okay, we need to go a little bit taller. And I'm actually going to just drag this one out a little bit as well. And then we can really start to see the graph and see what's happening. So we can use that graph now to answer the other questions. So find the height of the seat when t equals 0. So when t equals 0, t is my x value. It's essentially asking me for my y-intercept. So second function trace value, I want to know when x or t is equal to 0. And we can see there it's 2. So when t equals 0, the height is equal to 2. So the height of the like seat on the Ferris wheel is 2 meters at the point you get in, if you think about climbing up those stairs and then getting in. And then the seat first reaches a height of 20 meters after k minutes. So if you think about your graph here, you've got your kind of function, and it first reaches a height of 20 meters. So 20 meters is going to give us a time. So we're going to go back to y equals and plot the function of 20. And then we can solve that. So it's the first time it hits 20, which is here. So second function trace intersect. And there we go. We can find that it happens at 84.6. So k equals 84.6 to 3 significant figures. And then the last question is to calculate the time needed for the seat to complete the full rotation. So how long you're kind of sitting on that Ferris wheel for. We know that it starts at 2, and that seems to be our minimum value. We know that on our course we don't have any sort of shift left and right, and therefore you'll always start on either the minimum, the maximum, or the central point. We can see that this one is obviously the minimum. So the full cycle is until it gets back to a minimum. So I'm actually just going to find the minimum of my graph. So I'm going to go across to this minimum over here, and let's find the minimum point. And we can see that that happens when x is 300. So it takes 300 minutes in order to make the full rotation. That's how long you're going to be sat on that Ferris wheel for, if you're sat on it for the full circle, which makes sense because you wouldn't get off halfway through. So the marks for this one, there's 2 marks for the first question. And that's 2 marks just for your answer, or if you didn't get the answer but showed some working or substitution or method. The second question is 3 marks. So there's 1 for your method here, and then again 2 for your answer. These ones, the rounding really does matter. That's why they're worth 2 marks. So be careful with your rounding. And then the last one here, again, is for some sort of method, and then 2 marks for your answer. So your method can be showing that it's the minimum point and your full rotation. And you can just draw a little sketch of the graph in the test paper to show you're working.